This is Spacetime, Series 23, Episode 61. Coming up on Spacetime. New evidence suggests the first stars began shining far earlier than thought. Computer modelling proposes Planet 9 may not exist after all. And Europe's solar orbiter passes through the tail of Comet Atlas. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
A new study using some of the deepest images ever taken by NASA's Hubble Space Telescope suggests that the first stars in the universe probably began shining far earlier than previously thought. Cosmology tells us the universe exploded into existence out of a quantum singularity in what's commonly referred to as the Big Bang some 13.82 billion years ago. During its first picosecond of existence, the four fundamental forces of nature came into being. The first to split off was gravity. Nanoseconds later, the separation of the strong nuclear force from the electroweak force is thought to have triggered cosmic inflation, causing the universe to begin a hyper-accelerated expansion. It was during this period, which isn't well understood, that energy began transforming into a quark-gluon plasma of elemental subatomic particles, made up of equal amounts of matter and antimatter, which then quickly began annihilating, but mysteriously leaving a small excess amount of matter. Scientists still don't know why. About a second after the universe came into being, the first neutrinos are thought to have decoupled, and if primordial black holes ever existed, they would have formed around this time as well. Over the following seconds, quarks began forming composite subatomic particles, such as protons and neutrons. About 2 minutes after the universe came into being, conditions had cooled enough for nuclear synthesis to begin, with around a quarter of all the protons fusing with all the neutrons to create heavier elements, initially deuterium, which quickly fused into mainly helium-4. After the universe had reached the grand old age of 20 minutes, it was no longer hot enough for nuclear fusion to continue, but still too hot for neutral atoms to exist or photons to travel any significant distance before being reabsorbed. So the universe was this opaque plasma. Slowly over the next 47,000 years or so, it continued to cool, with matter eventually beginning to dominate over radiation. And by about 100,000 years after the Big Bang, helium hydride becomes the first molecule created. Much later, hydrogen will react with the helium hydride to form molecular hydrogen, the fuel needed to make stars. But it took some 380,000 years for the superheated, rapidly expanding universe to cool down sufficiently for electrons to combine with protons and create the first neutral atoms, an epoch known as recombination. And this allowed the universe to become transparent for the first time. The newly formed atoms, about 75% hydrogen and 25% helium, with trace amounts of lithium and beryllium, quickly reach their lowest energy or ground state by releasing photons. And as these photons decoupled, they bathed the universe in cosmic microwave background radiation, which still exists today as the faint afterglow of the Big Bang, but now cooled down to just 2.7 degrees above absolute zero. This cosmic microwave background radiation is the earliest known light in existence. It was also the only light in the universe, other than the 21-centimeter radio emissions occasionally emitted by hydrogen atoms. The decoupled photons would have filled the universe with a brilliant pale orange glow, which as space-time continued to expand, would have gradually redshifted into longer non-visible wavelengths after about 3 million years, leaving the cosmos without any visible light, a period which astronomers refer to as the cosmic dark ages. Meanwhile, under the influence of a mysterious yet-to-be-discovered substance known as dark matter, gravitational forces were drawing atoms of hydrogen and helium into a cosmic web-like structure of long filaments and connecting nodes that would eventually evolve into galaxies, galaxy clusters and superclusters surrounding vast empty voids. At some point between 150 million and 1 billion years after the Big Bang, cold clouds of molecular hydrogen and helium became dense enough to begin to collapse under their own gravity, producing temperatures and pressures high enough to trigger nuclear fusion, in the process generating the universe's first stars. The ultraviolet light produced from these first stars began to ionize the surrounding neutral hydrogen. This is the epoch of reionization. However, by now, matter had been diffused by the continuing expansion of space-time, and so the scattering interactions of photons and electrons were far less frequent than before electron-proton recombination. This meant that the universe became filled with a low-density ionized hydrogen and remained transparent, in the process giving us the universe we see around us. But the exact time when these first stars began to shine, initiating the epoch of reionization, remains a mystery. The new findings, reported in the monthly notices of the Royal Astronomical Society, have now narrowed the timing of this event to somewhere within the first 500 million years after the Big Bang. The conclusion is based on the observation of distant galaxies seen by the Hubble Space Telescope through gravitational lensing, which show no evidence of any population 3 stars. And that's important, because population 3 stars were these very first stars to have formed in the universe. And they were very different, therefore easily identifiable, from all the subsequent generations of stars that followed. These primordial stars were forged out of the pristine hydrogen and helium, with trace amounts of lithium and beryllium, which were the only elements created in the Big Bang. All the other elements in the universe, which astronomers collectively refer to as metals, were either first created through nuclear fusion in the course of those population 3 stars, such as carbon, oxygen, neon, sodium, magnesium, silicon, sulfur, argon, aluminum, calcium, nitrogen, nickel and iron, or when those first stars died in supernova explosions. The metals produced by these first ever stars would then go on to be incorporated into all subsequent generations of stars, as well as planets and moons and asteroids, and eventually life. The name Population 3 arose because in the 1940s Walter Baade classified metal-rich stars found in the disk of the Milky Way, such as the Sun, as Population 1 stars. And older stars with lower levels of metallicity, the stars which went on to produce the Population 1 stars, and which nowadays are commonly found in the Milky Way's bulge, halo and globular clusters, became known as Population 2 stars. Because of their unique origins and compositions, Population 3 stars were all thought to have formed as massive O and B blue stars, anywhere between 60 and 300 times the mass of our Sun. These might very well have been the biggest stars ever to have existed. And being so massive, they would have exhausted their nuclear fuel supplies in just a few million years or so, before exploding as core-collapsed supernovae and seeding the universe with the elements needed to make the Population 2 and 1 stars we see today. The new Hubble results suggest the formation of these first stars and galaxies in the early universe must have taken place far earlier than previously thought, at least more than the 13.3 billion years back in space-time, which Hubble can see. The study's lead author, Rakana Batwadeka from the European Space Agency, probed the early universe from around 500 million to a billion years after the Big Bang by studying the galaxy cluster MACS J0416, using both the Hubble and Spitzer space telescopes, as well as ground-based observations using the European Southern Observatory's Very Large Telescope, the VLT, in Chile. The results were achieved using Hubble's Wide-Field Camera 3 and Advanced Camera for Surveys as part of the Hubble Frontier Fields program. Owing to the expansion of space-time, the light from these distant galaxies has been shifted from ultraviolet and optical wavelengths into the infrared part of the electromagnetic spectrum. And Hubble's Wide-Field Camera 3 is equipped to probe that part of the spectrum, while the telescope's Advanced Camera for Surveys is optimized for visible light observations. This program, which observed 6 distant galaxy clusters from 2012 to 2017, produced the deepest observations ever made of galaxy clusters, as well as the galaxies behind them, which had been magnified by the gravitational lensing from the foreground clusters. This revealed galaxies between 10 and 100 times fainter than anything previously observed. That's because the immense masses of the foreground galaxy clusters are large enough to bend and magnify the light from the more distant objects behind them. This allows Hubble to use these cosmic magnifying glasses to study objects that are beyond its normal operational capabilities. The authors also developed a new technique which effectively removes the light from the bright foreground galaxies that constitute these gravitational lenses. And this allowed them to discover background galaxies with lower masses than had ever previously been observed with Hubble, at distances corresponding to when the universe was less than a billion years old. At this point in cosmic time, the lack of any evidence of exotic stellar populations and the identification of many low-mass stars supports the suggestion that these galaxies are the most likely candidates for the reionization of the universe. The results have profound astrophysical consequences because they show that galaxies must have formed far earlier than previously thought. It also supports the idea that faint low-mass galaxies in the very early universe must have been responsible for the epoch of reionization. This is Spacetime. Still to come, new evidence suggests Planet 9 may not exist, and the European Space Agency's solar orbiter passes through the tail of Comet Atlas. All that and more still to come on Spacetime. A new study suggests that the long-sought-after Planet 9 may not exist after all. Astronomers first hypothesized the existence of a mysterious ninth planet in 2016, after observing the strange elongated orbits of 13 distant Kuiper Belt objects. The Kuiper Belt is a ring of frozen worlds, comets, and icy debris circling the Sun out beyond the orbit of Neptune. The unusual orbits of these 13 tiny worlds could best be explained by gravitational perturbations caused by some far-flung giant planet, somewhere between 5 and 10 times the mass of the Earth, on an orbit ranging from between 300 and 700 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometers or 8.3 light minutes. The idea of a Planet 9 also seemed to make sense based on models of the early solar system. You see, they suggest that as the gas giants Jupiter and Saturn migrated out to their current orbits, they affected the orbits of the two ice giants Uranus and Neptune, causing them to both swap their orbital positions and move further out into the solar system, while at the same time flinging an additional unknown planet either further out into the outer solar system or even beyond that into interstellar space. Intensive ongoing searches for this mysterious Planet 9 have so far proven to be unsuccessful. And according to this new study, the reason may be that this planet simply doesn't exist. The idea is that the 13 Kuiper Belt objects are being gravitationally shepherded not by a single super-Earth-sized planet, but instead by the combined gravitational force of a huge rotating ring of lots of small icy chunks scattered across a wide area. The new hypothesis is supported by OSIS, the Outer Solar System's Origin Survey, which has used the Canada-France-Hawaii telescope to discover and track more than 800 new Kuiper Belt objects, nearly doubling the number of known worlds with well-measured orbits in this dark outer region of the solar system. These newly found objects range in size from just a few kilometers to more than 100 kilometers across, and are mostly orbiting at distances of around 40 to 42 astronomical units, though some are as much as 100 astronomical units away. Meanwhile, a separate study, this one using data from the Dark Energy Survey, has discovered more than 300 additional Kuiper Belt objects in just one small quadrant, suggesting that there are far more Kuiper Belt objects still out there waiting to be found. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
Planet 9, yes or no?
Oh dear. It's still possible it might turn up, Andrew. This is not a death sentence for the idea of Planet 9. So let's just go back to what it's all about. This story goes back, I think, about 4 years now, to two separate groups of astronomers who are interested in the outer solar system. And the observations were made, and these were the groups of astronomers of some significance. These are the top guys in their field. But they noted that the icy asteroids out there in the depths of the solar systems are things we call Kuiper Belt objects or trans-Neptunian objects. They're slightly different of those two things, but we can lump them all together. We know that they have extremely elliptical orbits, very elongated. And what they noticed was that the direction of the elongation of these orbits all seem to cluster in one particular direction. And so these two separate groups of researchers, they did calculations on why this might be, why there's this sort of clustering of the alignment of the orbits. And what popped out of the calculations was a very large and very distant planet that would maybe be shepherding the orbits into the same alignment. In fact, that these groups came to the conclusion that that was the only thing that could keep these orbits sort of narrowed down down to that bit of the solar system, and hence the theory of Planet 9, which is assumed to be 5 to 10 times more massive than the Earth, orbits that carry it way, way beyond the solar system. I mean, its nearest is 10 times away as far as Neptune is. This is the hypothetical planet, and more than 20 times farther away, 30 times perhaps farther away at its aphelion, the furthest point from the sun. Lots of predictions been published as to where it is, but nobody's found it. One of the problems is that the predictions place the planet pretty firmly in the Milky Way, where you're really struggling because there's so many stars. And what you're looking for is something very faint that's moving very slowly among a really rich star field. And that is intrinsically something that's very hard to find. So what is happening now? Well, I think there are two groups involved here, but I'm going to talk about one. And this comes actually from a conversation article written by one of the members of this group, Samantha Lawler. This group of scientists is called OSOS, which is a great name. OSOS is maybe it's OSOS in America. It's an acronym.
Could be.
Outer Solar System Origins Survey. Very nice name, Outer Solar System Origins Survey. And they actually coming to a conclusion that maybe we've been led astray. And that's because these objects are so difficult to observe that, generally speaking, the Kuiper Belt objects are a long way off. They're small objects. Some of them are only a few kilometers across. And when you think of the distances, you really have a problem. They're so faint. And what they're saying basically is that the ones that have been found maybe have been found preferentially. They've been at advantageous positions in their orbits and advantageous directions. And they're suggesting that our knowledge so far of the Kuiper Belt is highly biased. In other words, there's a lot more there than we have yet seen. The biasing comes from these preferential positions where the objects are that have been found so far. And so OSOS program has discovered some new, they're actually called extreme Kuiper Belt objects because they've got this extreme eccentricity or elongation of the orbit. They've discovered what they describe as a handful of these. There is another survey that's found over 300 of them. And both of these two new sets of discoveries can be shown to be, as Samantha puts it, they are statistically consistent with a uniform distribution. That means that the bias in a particular direction has gone away. And what she says is, so now two independent surveys, both of which carefully tracked and reported their observational biases in discovering independent sets of extreme KBOs, Kuiper Belt objects, have found no evidence for clustered orbits. So very, very interesting. They've done further work to test the Planet 9 theory, and even the most extreme of the ones that basically been suggested in support of Planet 9, their extreme orbits, they're very essentially very elongated orbits, can be explained by known physical effects. That's what they say. So
the likelihood of a Planet 9 is much reduced, but not an absolute write-off yet. But it sounds like what they're saying is that the multitude of objects out there is probably more likely to be the influence than one massive object.
Yes, that's right. Exactly. So, and the fact that we're only seeing a small number of these objects, and it just happens that the ones we've seen all line up in a way that's probably more to do with where we've seen them in their orbits than a real effect. As I said, it's not a death sentence, but it calms things down. It suggests that maybe the Planet 9 theory was a little bit premature. Actually, this article ends, I think, in a very nice way. Samantha Lawler obviously has a way with words. She says at the end, many beautiful and surprising objects remain to be discovered in the mysterious outer solar system, but I don't believe that Planet 9 is one of them. So there you are.
That's a soft landing on a very disappointing revelation.
Yeah. But don't give up on it. I'm sure there'll be people still looking for it, because that's kind of what happens. That's how Neptune was found. The evidence for Neptune was, I think, a lot more convincing than the evidence for Planet 9. And sure enough, it turned up pretty well exactly where they predicted it back in the 1840s. But we're dealing with something quite different here, I think. It's a statistical... With Neptune, led to the discovery was hard calculations evidence on orbital dynamics of actually the planets Uranus and the inner planets, that you can work out from the orbits of Uranus in particular that there's something else out there. With this, what we're talking about is statistics over a large number of objects that point to the existence of Planet 9. Bottom line might be that we just haven't been looking at a large enough number of objects, that we've been selective about what we're seeing.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, Solar Orbiter passes through the tail of the Comet Atlas. And later in the science report, discovery that at least one part of the Earth is still pristine and unchanged by humans. All that and more still to come on Space Time. The European Space Agency's Solar Orbiter spacecraft has passed through the tail of the remains of Comet Atlas. The recently launched probe wasn't meant to be taking science data quite so soon. However, mission managers worked to ensure that the four most relevant science instruments were online for the unique encounter. Solar Orbiter was launched on the 10th of February 2020. Since then, and with the exception of a brief shutdown due to the coronavirus pandemic, scientists and engineers have been conducting a series of tests and set-up routines known as commissioning. The original completion date for this phase of the mission was set for June the 15th, so that the spacecraft will be fully functional for its first close-up pass of the Sun, known as perihelion, over the next few days. However, the discovery of a chance encounter with Comet Atlas has caused a change in the schedule. Serendipitously flying through a comet's tail is a rare event for a space mission, something that's only ever happened 6 times before for missions that weren't specifically chasing comets, and all those were discovered in spacecraft data following the encounter. So, Solar Orbiter's encounter will be the first to have been predicted in advance. It was noticed by Grant Jones from the University College London. Jones detected his first accidental comet crossing back in the year 2000 while investigating strange readings in data recorded by the Ulysses spacecraft in 1996. Ulysses was studying the Sun from above the ecliptic, the imaginary plane around the Sun upon which the planets all roughly orbit. He discovered that Ulysses had passed through the tail of the comet Hakodate, also known as the Great Comet of 1996. Soon after that announcement, Ulysses crossed the tail of another comet, and then a third in 2007. So, fast forward to May 2020, and Jones realized that Solar Orbiter was going to be some 44 million kilometers downstream of the comet C2019 Y4 Atlas this month. And so he alerted ESA mission managers. Solar Orbiter is equipped with a suite of 10 science instruments designed to study the Sun and the solar wind, the flow of charged particles constantly pumped out by the Sun into space. And 4 of those instruments were perfect for detecting the comet's tails because they measure the conditions around the spacecraft, and so they could return data about the dust grains and the electrically charged particles given off by the comet. These emissions create the comet's 2 tails, the dust tail that's left behind in the comet's orbit, and the ion tail, which points directly in the opposite direction from the Sun. Solar Orbiter crossed the ion tail of Comet Atlas on June the 1st, and then the dust tail on June the 6th. Now, scientists are still sifting through the data, but if the ion tail's dense enough, Solar Orbiter's magnetometer would have detected variations of the interplanetary magnetic field. That's because of its interaction with the ions from the comet's tail. And the solar wind analyzer might have captured some of the tail's particles. Now, as Solar Orbiter crossed the dust tail, it's possible that tiny dust grains would have slammed into the spacecraft at speeds of tens of kilometers per second. They wouldn't have damaged the spacecraft, but they would have vaporized the dust grains, resulting in tiny clouds of electrically charged gas, which might have been detected by the Radio and Plasma Waves instrument. Comet Atlas was discovered back on the 28th of December 2019, and for a while there, it looked like it was going to become a major, spectacular naked-eye comet by May. However, in April came the news that Comet Atlas had in fact broken apart, the fragmentation continuing through May. The encounter has allowed scientists to learn more about these frozen visitors from the outer solar system. Solar Orbiter is currently circling the Sun between the orbits of Venus and Mercury, its first perihelion occurring at 77 million kilometers from the Sun. Now, over the coming years, Solar Orbiter will get much closer than that, passing within the orbit of Mercury, around 42 million kilometers from the solar surface. Meanwhile, Comet Atlas, or what's left of it, reached its perihelion at around 37 million kilometres from the Sun on the last day of May. This is Spacetime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have discovered a region of Earth's atmosphere that appears to be pristine and unchanged by human-related activities. A report in the Journal of the Proceedings of the National Academy of Sciences has identified a boundary layer of air that feeds the lower clouds over the Southern Ocean south of 40 degrees south latitude, which is free of particles called aerosols produced by anthropogenic activities or transported from distant lands. The study by Colorado State University is the first to measure bioaerosol composition over the Southern Ocean. The findings are fascinating because weather and climate are such complex processes connecting every part of the world with every other part. And climate change, caused by the human use of fossil fuels, has been rapidly affecting the atmosphere, making it difficult to find any area or process on Earth untouched by people. Scientists say Australia's most elusive bird, the night parrot, may not be much better at seeing in the dark than other parrots active during the day. The study by researchers at Flinders University has revealed that the critically endangered parrot's visual system is not as well adapted for life in the dark as what one would expect from a nocturnal bird. And that's raised concerns that it might adversely be impacted by things like fencing in Australia's outback. The findings, published in the journal Scientific Reports, are based on computer tomography scans of the only known intact skull of this exceedingly rare species, and then comparing it to skulls from other closely related parrots. Archaeologists have found what, for now at least, is the earliest and largest known structure ever built by the Mayan civilization. A report in the journal Nature claims scientists used airborne remote sensing laser technology to create three-dimensional maps which uncovered the previously unknown site in Tabasco, Mexico. The site consists of a massive 1.4 kilometre long by 0.4 kilometre wide platform, standing some 10 to 15 metres above the surrounding landscape. Unlike other archaeological sites from around the same period in Central America, this newly discovered site doesn't appear to have any clear indication of social inequality, such as sculptures of high-status individuals. Anthropologists say this suggests the importance of communal work in the initial development of the Maya civilization. Well, any look across the interwebs at funny memes or videos will show you that men tend to die a lot earlier than women because they do some really stupid stuff. But now a new study has examined exactly how sex really does influence the lifespan and aging rate of mammals. We all know that women typically live longer than men, but determining whether this same phenomenon also occurs in other species has been challenging. So scientists developed demographic data and developed 8 specific mortality estimates for more than 134 populations of 101 different species of mammals. Whereas the lifespan of females is on average 7.8% longer than that of males in humans, wild female mammals had on average an 18.6% longer lifespan than their male counterparts. And female mammals had longer lifespans compared with male mammals in some 60% of all the analysed populations. However, the authors didn't find significant sex-dependent differences in aging rates. The results suggest that it's local environmental conditions which are influencing sex differences in mortality patterns. Controversial cook Pete Evans is back in the news, with the Therapeutic Goods Administration fining him $25,000 for claiming his so-called biocharger can fight the coronavirus. Evans, who has just parted ways with longtime employer Channel 7, has been heavily slammed for promotion of an interview with racist conspiracy theorist and British Holocaust denier Dirty Dave Icke, an individual with a reputation for never letting a few facts get in the way of a good story. Now, there's no suggestion that Evans himself holds any anti-Semitic or racist views. Icke simultaneously claims COVID-19 is a fake pandemic with no actual virus, while at the same time linking the virus to 5G cell tower installations. The Therapeutic Goods Administration found claims made by Evans about his biocharger, in reality just a glorified 15-grand lamp, were likely to take advantage of the vulnerability of consumers who are ill, were likely to result in consumers not seeking medical advice at an appropriate time, and were likely to have a negative impact on public health. Evans won the Australian Skeptics 2015 Ben Spoon Award for promoting pseudoscientific piffle for his diet promotions, campaigns against fluoridation, and support for anti-vaxxers. A year earlier, in 2014, Evans claimed his so-called paleo diet could prevent autism. It can't. And in 2016, Evans was widely condemned by medical professionals after giving advice to an osteoporosis sufferer to stop consuming dairy products, wrongly claiming that calcium from dairy can remove the calcium in your bones. In 2018, Evans again outraged medical experts after promoting the idea that instead of using sunscreens, you should simply look directly at the sun during sunrise and sunset without any means of protection. Again, totally wrong, and also extremely dangerous. You should never look directly at the sun. Numerous high-profile Australian medical experts have warned about the grave dangers of following Evans' advice. These include Michael Gannon, the president of the Australian Medical Association, general practitioner Brad McKay, and obstetrician Brad Robinson, while the national president of the Australian College of General Practitioners, Harry Nespolon, suggested that Evans should stick to almonds. A view shared by Tim Mendham from Australian Skeptics.
Pete Evans has been sort of promoting a whole range of different things over the last few years, including staring at the sun to give you a morning boost, and of course his paleo diet, which featured offering bone broth to babies. He's a supporter of homeopathy, he's against fluoride, there's a lot of alternative stuff, but the recent one really raised the ire of the Therapeutic Goods Administration, which was his biocharger machine, which he promoted on YouTube, which is basically, it looks like a Tesla coil with a few coloured lights around it, and it was supposed to be able to cure or treat hundreds and perhaps thousands of different ailments, including, as he called it, the Wuhan coronavirus. Now, sort of suggesting that anything can cure that at the moment is sort of a bit of a no-no.
Well, firstly, that's getting the sort of thing doctors do. It's also dangerous because people who need treatment may not get treatment if they take his advice.
Absolutely right. And, of course, it was costing $15,000 for this machine, but he got fined $25,000 by the TGA for his advertising of this product. So really, if he only sold two, he's covered the fine. But never mind. The TGA's been cramping down a bit more on this COVID stuff recently. Just the other day or so, it fined the Genesis 2 Church, and a company that was sort of selling this bleach as a coronavirus cure. They got fined $150,000. And so there's a little bit of action there, which is great to see.
What does one do with the bleach, I fear to ask?
You ingest it. It's actually marketed as a miracle mineral solution, so it partially contains bleach products and that sort of stuff. It's the same people who are selling it in America.
Pass the Kool-Aid.
It is a bit, but yes.
Don't swallow bleach.
Genesis Church of Health. And it's under a company here called Miracle Mineral Supplements, and got a range of products and things, and they've been told to take it down.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download Spacetime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the Spacetime online shop and grabbing yourself a few goodies, or by becoming a Spacetime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more Spacetime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at Spacetime with Stuart Gary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.